Hello students, in this video I want to explain preparation of haloalkanes under the chapter haloalkanes and haloarine. Here first you see that haloalkanes can be prepared from alcohol. When alcohol is treated with hydrogen halide HX, X stands for Cl, Br and I, the nucleophilic substitution of OH gives rise the halide. So now follow that among HCl, HBr and HI, if we follow the reactivity order is towards the HI as the size of the halogen atom from chlorine, bromine towards the iodine is increasing, and therefore the bond dissociation enthalpy of these halides is gradually decreasing. Therefore HI is most reactive and can form the nucleophile I- very easily, and the substitution takes place, OH being substituted by the iodide as well as bromide. But when it is the turn of HCl, the bond is being stronger, its dissociation enthalpy is higher. For that to break the hydrogen and chlorine bond, a Lewis acid catalyst ZnCl2 is used. Lewis acid catalyst ZnCl2 is used, which helps to break the bond between hydrogen and chlorine. The Cl minus is formed like this. Chlorine with 2 electron combines with ZnCl to form ZnCl3 minus, which then further break down into Cl minus, forming ZnCl2 again. So ZnCl2 is back. That is, it is acting as a Lewis acid catalyst, forming the Cl minus, which helps to substitute the alcoholic group in this manner, forming the alkyl chloride. Now this HCl and HBr can be prepared by other way when reacting with sodium bromide or potassium bromide, or sodium chloride or potassium chloride with concentrate H2SO4, forming the alkyl bromide and alkyl chloride. But the formation of HI by reaction between the concentrate sulfuric acid and potassium iodide is not suitable, as because concentrate sulfuric acid is a strong oxidizing agent and it oxidizes again the HI formed into iodine. So it is I2 will be formed. Now here we can use H3PO4 instead of concentrate sulfuric acid to form the HI that helps formation of alkyl iodide. That is, in this process the hydrogen halide is prepared in situ from the alkyl halide with acid. Now next process of preparation of alkyl halide is from phosphorus halides. When PX3 means PCl3 and PBr3 is reacting with alcohol, it gives rise alkyl halide, and the byproduct is phosphorus acid. And here another way is using red phosphorus and halogen. Since PBr3, PI3 they are very unstable, therefore it can be prepared from reaction between red phosphorus and halogen, forming the alkyl chloride, alkyl iodide and alkyl bromide. Here I have written some examples also. When PCl3 or PBr3 is used, propanol is giving 1 bromopropane or 1 chloropropane, and here red phosphorus, bromine or iodine. From isopropyl alcohol we can give isopropyl bromide or isopropyl iodide. Now to substitute OH with Cl, we can use phosphorus pentachloride, PCl5. So here the alkyl chloride is formed, and from phosphorus pentachloride 2 chlorine atoms are being substituted, forming phosphorus oxychloride, POCl3, along with HCl. So here is an example. From ethanol we can get chloroethane when it is reacted with phosphorus pentachloride. Now, to bring the chloride from alcohol, the best reagent is thionyl chloride. When alcohol is reacted with thionyl chloride, the alkyl halide that is formed, it is along with that two gaseous byproducts are there, sulfur dioxide and HCl, they are going out from the system. So the extraction of the alkyl halide can be obtained in the reaction medium. So collection of the alkyl halide is being suitable. Here benzyl alcohol, it is not an aromatic alcohol, it is aliphatic alcohol. When treated with thionyl chloride, you can get benzyl chloride. Here you can follow that phenol. From phenol, the OH group cannot be substituted by this method with the halides, because the OH group can show the plus R effect by donation of electron into the ring, and there being a partial double bond character between the carbon and oxygen atom. Therefore, breaking of this oxygen carbon bond by a nucleophile X minus, that is Cl minus, Br minus or I minus, is very much difficult. Therefore, phenol by this process, that means phenol reacting with HCl or phenol reacting with HBr, phenol reacting with HI, giving rise the corresponding halide, is not suitable. Here you follow some other methods also for preparation of haloalkane. Number 2 method is by free radical halogenation substitution reaction. When halogen, chlorine and bromine is reacting with an alkane, with a hydrocarbon in presence of diffuse sunlight or heat, we get the corresponding chloro or bromo substituted product. This reaction follows a free radical intermediate mechanism, where you can follow from this unsymmetrical, this compound, we can get two different types of free radical. That means this 2 degree free radical and the 1 degree free radical. Since the 2 degree free radical is being more stable, therefore the 2 chloro or 2 bromo substituted product will be major. Next, number 3 method, we can get haloalkane from alkene by hydrohalogenation, addition of HX. Means when alkene is treated with HX, hydrogen chloride, bromide or iodide, the corresponding chloride, bromide or iodide product is formed by following Markovnikov's rule. This rule states that when an unsymmetrical alkene is reacted with an ionic compound like HX, where X is being partially negative due to its higher electronegativity and hydrogen is being partially positive, the negative part goes to that carbon where the number of hydrogen atom is less. It is because it follows a carbocation intermediate mechanism. You can follow that the 2 degree carbocation formed from here is being more stable than the 1 degree carbocation. Therefore, the 2 halo product, haloalkane, the haloalkane coming from the more stable carbocation is becoming the major product. And if this one is reacted with HBr, as we know that peroxide effect means addition of HBr in presence of peroxide gives rise the bromoalkane by following anti-Markovnikov rule, and in this case it goes through a free radical mechanism where after addition of the halide from HBr, a free radical is formed. So the bromine atom in this alkene is being attached, or rather bromine free radical is being attached at the terminal carbon, so that the 2 degree free radical is formed here. If the Br is coming at the middle, this CH2 carbon holds the free radical, so it will be 1 degree free radical, less stable one. So that's why here we get the product, the anti-Markovnikov product, 1 bromo alkane, that is 1 bromo propane here. Next, halogenation of alkene. This gives rise dihalide compounds. The very important one is bromination of alkene, where the color of bromine is reddish brown, which gets decolorized due to addition of bromine in alkene compounds. So we can follow that. Here we are getting the dihalide, the vicinal dihalide, and if this reaction is carried out in presence of nonpolar solvent like CCl4, we get the dihalide, vicinal dihalide. But if the compound is bromine is added in presence of polar solvent like water, so you can follow that bromine reacts with water to form HBr and HOBr. This HOBr is in which oxygen part is being more electronegative and negative, and Br part is partially positive. So therefore, following the Markovnikov's rule, the OH group gets attached to the middle carbon and the bromine being attached to the terminal carbon. So you can follow that due to difference in solvent nature, nonpolar solvent gives dihalide, but polar solvent does not give the dihalide. So this is the addition product obtained. So these are the few ways of preparation of haloalkane. Thank you.